Of this video is to give you some hints and explain a few things about the Sudoku constraint satisfaction programming assignment. So the purpose of this first assignment is to gain some first-hand experience of what it means to develop AI or AI software. In this particular example, you write some software with very little effort, 2 to 4 hours, depends on whether you get stuck or not, that solves Sudoku problems. Again, Sudoku problems, as we discussed in class, are considered challenging, right? I mean, requiring some serious brain power. But your software will solve this thing in a fraction of a second. It just really will be much more powerful, much better, so to speak, than you ever will be. And so to drive home the point, I'm asking you to implement and test a backtracking algorithm, the one that we discussed in the slides, in the prior slides. And it's an individual assignment. So your software needs to read a file as follows. The first number, which appears on the row itself, represents the size of the board. So in this particular example, we have a 9 by 9. But I also have some 16 by 16, 25 by 25, and 36 by 36 problems. The good news is the starter code that I provide you does all this stuff. So your software should output a solution if it exists. So, obviously instead of the 0, we have something else here. Or a comment stating that no solution exists. And that's for your own edification. You can sort of like print this thing out and pretty quickly see whether, is this a consistent solution or not. But for grading purposes, I also ask you to output your solution to a file. And so the file name needs to be whatever our test data file name is, say Sudoku 9 easy, and you add solution to that file name. So that's what it has to be. Again, so if no solution exists, simply write -1 to the file. So don't output anything else. Also the solutions, don't put the grid size in it, just the numbers. That's all we need. So this is a warm-up exercise that's worth 40 points. And again, I ask to implement a basic backtracking solver. As I said, it'll solve 9 by 9 problems in a fraction of a second. Try the 16 by 16. You're probably going to give up after a couple of minutes. I'll say more about that later. So I provide you with some starter code and some test data. I'll say more about that here in a moment. What you need to submit are 4 things, really. A file called name.txt, which just contains your first and last name. Again, I have some grading software that uses the same test data as we make available, and it produces a grader report that makes it a little bit easier for us to grade this stuff. Obviously your code, and then your solution files that you output as part of this portion, or that you produce as part of this portion. And then, and this is really important, a half-page single-spaced write-up in which you address the following question. Clearly, solving Sudoku problems requires a good amount of intelligence. In what sense is your software intelligent? And so again, save this file as essay.txt. If you're interested in gaining some extra credit, see whether you can develop solutions for 16 by 16, 25 by 25, or 36 by 36. In order to do so, you will most likely have to implement something like the AC3 algorithm. You have to add inference to this thing. I'll talk about the AC3 algorithm in the next slide presentation. For the 25 by 25 and 36 by 36, even the best inference is not going to do much for us. And so you have to have a dynamite data structure. It's a complexity problem. Called dancing links. That's most likely what you want to do. If you want to do this thing, please talk to me first. We can negotiate point values as well as a deadline for this extra portion of the assignment. So let's have a look at the code. The code that I'm going to show you is very similar to the one that I posted. I made some slight modifications since. But the reason I'm talking about this one here is because it has a few hints about how to implement this thing. So I read in the board as a 2-dimensional array. That's the starter code that I give you. And then I put in values for the given ones. And if there's a 0, I have a separate data structure. I create a variable for this thing. I also print out the input, so it's always nicer to see what it is. And then you should print out the solution at some point in time. So if there's a solution, I also have some code to print it out. If there's no solution, I simply print out no solution found. So all that stuff is already there. The starter code that I give you has a call to solve with no argument. So I'm just simply going to indicate to you a little bit how I solve this thing. So my solve has a list, an array list of variables, the data structure that I created, and then the two-dimensional array. And so I call solve, and this is the main backtracking algorithm. At some point in time, I need to make sure that a tentative or a value that I select is actually consistent. And if it is, it returns true, and then I make that temporary assignment. This one here is just, for the boxes. I get the numbers for the boxes, support function, and here I know that I'm done. So all the assignments have been made. So again, I don't want to show you my code, but over here, the tricky thing is that, remember, you need to backtrack at some point in time. So if we try a cell and we try 1, 2, 3, 4, 5 all the way up to 9, and none of them are consistent, right? I mean, this one always returns false. Then you need to backtrack. And so what you need to do is you need to make sure that if you made some modification to the two-dimensional array as part of the consistency check, you need to undo that. Okay? You need to set it back to 0. But then you also need to make sure that you understand which assignment you were working on, and you need to set that thing also to 0, okay? Or indicate in your data structure that, yeah, I have to start over again. And then when you go back, you should be able to, the recursion should be able to put you back to the assignment you were working on, and then you simply increase it by 1. Okay, so again, I don't want to say too much about this thing. Part of the challenge of this assignment is to sort of like figure out how to do that. But you should be able to do that. If you have any questions, you just talk to me. All right, send me an email or talk to me during my office hours. Alrighty, folks, I hope that is it. Good luck and enjoy. Bye.